Chapter 5 is going to cover populations. Section 5-1 will cover how populations grow. And there are certain characteristics that determine how populations grow. The three important characteristics of populations are their geographic distribution, density, and growth rate. So let's first define geographic distribution. Geographic distribution or the other term we call geographic distribution is the range, is the area that is inhabited by a population, or commonly known as where the population lives. Range can vary from a few cubic centimeters occupied by a bacteria in a rotting apple to the millions of square kilometers occupied by migrating whales. One thing that you have to remember when we are talking about population in this particular chapter is we're not specifically focusing on human population, but we're talking about populations of any type of organism. Once again, it can be ranging from the bacteria to whales. We might talk about populations of giraffes. We might talk about populations of fungi. It really doesn't matter what we're looking at. It's just that it's a population of some type of living organism. Population density is the number of individuals per unit area. And density is something that you have worked with in physical science before. So the question would be, how does population grow? So now we're going to talk specifically about the growth rate. There are three factors that can affect population size. That would be the number of births, the number of deaths, and finally, the number of individuals that enter or leave the population. And I know that you've heard of the terms that refer to individuals that enter or leave the population. Populations grow if more individuals are born than die in any given period. The term for individuals that enter a population is called immigration, and this will cause the population to increase. The term for individuals who leave an area is called emigration, and this causes the population to decrease. So once again, immigration, movement of individuals into an area, causes the population to increase. Emigration is movement of individuals out of an area and causes the population to decrease. There are two different types of growth rates that we're going to look at. The first one is called exponential growth, and you have worked with exponents in math class before, so this should be very familiar to you. If a population has, and this is one of the key things, has an abundant space, food, and is protected from predators and disease, the organisms in that population will multiply. So in an exponential growth pattern, that means that there are no predators present, there's no disease present, there's nothing that can affect the population. So the population just continues to grow and grow and grow. So here would be the definition of exponential growth. Exponential growth occurs when the individuals in a population reproduce at a constant rate. And you know what exponents are. You have dealt with them before, like 10 to the first, or 9 to the third power, or 100 to the 14th power. So these are exponents, and we know how to calculate exponents. 9 to the third power would be 9 times 9, and whatever that is, which is 81, and then we're going to multiply it again by 9. So that gives you then the amount of exponential growth. We have a loud dog today. The pattern of growth for an exponential growth is going to be what is called a J-shaped curve. And as you can see from looking at the curve, it is similar to the letter J. So the exponential growth is a J-shaped curve. The number of individuals in an exponentially growing population slowly increases in the beginning, and then, as you can see over time, it becomes larger and larger until it approaches an infinitely large size. So then, once again, this is going to be exponential, because if you start low with 2 to the first power, that equals 2. 2 to the second power equals 4. 2 to the third power is 2 times 2 times 2, which is going to equal 8. So you can see how it starts very slowly, and then as you increase, it gets very large very quickly. The other type of growth pattern is called logistic growth. And in logistic growth, as the resources become less available, growth of the population slows or stops. So once again, in logistic growth, resources become less available and the growth of a population slows or stops. So the definition of logistic growth is that it occurs when a population's growth slows or stops following, and that's a key right here, following a period of exponential growth. And this particular pattern for logistic growth is called an S-shaped curve. The reason it's an S-shaped curve is because we start out exponentially, and then you can see growth tapers out. So we start out quick, and then it slows down. So that's why we call this, in logistic growth, an S-shaped curve. Population growth slows down when the birth rate goes down, the death rate goes up, or both events occur at the same time. When the population has leveled off, average growth rate has reached 0. Carrying capacity is the largest number of individuals that a given environment can support, which means that when we're looking at our S-shaped curve, the carrying capacity is where you will see no more growth happening. And I have a graph on the final slide that will indicate where you might draw a carrying capacity line. In the natural world, most populations follow a logistic growth. So once again, in the natural world, most populations follow the logistic growth, which is your S-shaped curve. And in the last slide, you can see the two different types of curves that we're looking at. You have your exponential one, that is your J-shaped curve. You have your logistic one, which is your S-shaped curve. And carrying capacity is where you no longer see growth taking place. So where growth has basically leveled off is where you're going to see carrying capacity. This concludes podcast 5-1.